Thank you for tuning in to Demystifying Math. In this lesson, we're going to be graphing piecewise functions. A piecewise function is one that has different formulas for different parts of its domain. For this particular function that we have here, where our x values are greater than or equal to 0, we're going to be using the graph of f of x equals 2x, or you can say y equals 2x. For any of our x values that are negative, we're going to be using the graph of y equals negative 1/2 x. So let's look at our first part. We have the graph of y equals 2x. Now notice that I only drew part of the graph. I actually drew the right half there. And that's because for that part of the graph, my domain is restricted to be greater than or equal to 0. So at 0, if I put a 0 into the function, I would get out 0. So 0, 0 is like an endpoint on that part of the graph. And then it goes off to infinity. Now, for the other side of the graph, we're going to have the function negative 1/2 x, which is linear also. It has a slope of negative 1/2 and a y-intercept at 0. Now, even though the order pair 0, 0 is not included, because of the domain restriction being strictly less than 0, we're still going to put a circle at 0, 0. Now, it would be an open circle there, but since we already have the point of 0, 0 on the other side of the graph, we don't want to get rid of it. All right, so it's still going to be a point there. It's just a point that's caused by the first part of the graph rather than the second part. So we have our piecewise graph drawn. Okay, let's do one that involves a quadratic. So for this particular one, you're going to follow the path of x squared for any x values that are not equal to 2. So it's going to be x squared everywhere except at x equals 2. So that's causing us to have a little bit of a hole in our graph at 2, 4, which we normally would have if we plug 2 into the x squared graph. Instead of having the ordered pair at 2, 4, we have an ordered pair at 2, 0, which is on that x-axis there. So we have that hole in the graph, but we still have the ordered pair 2, 0, which means that our domain is still our reals. So we're not excluding that particular point from the graph, we just have it not following the path of x squared. Okay, let's try this one. We have the output being 3 for all the x values greater than or equal to 2. Our output is 1 for any x values between 0 and 2. And it's going to be a negative 1 output for any x values less than or equal to 0. So for the first part of the graph, for any x values greater than or equal to 2, the output is always 3, which means that we have this horizontal line going through the y equals 3. But we're not graphing the entire line because our domain is restricted to be greater than or equal to 2. We do have a closed endpoint at 2 because it has the or equal to sign in our function. For the second part of the graph, it's going to lie between 0 and 2, and the output is always 1. So we have the horizontal line at y equals 1. Notice on this part of the graph, we have open circles on each end, because in this case we do not have the or equal to signs on our inequalities. So we're not including the endpoint where x equals 0 or where x equals 2. Okay, for the third part of our graph, our x values are less than or equal to 0, which means it includes 0 as an endpoint, and the output's always negative 1. So again, we have a horizontal line at y equals, in this case, negative 1. So there's our graph. Okay, for the next one we have x squared plus 2 for any x values greater than or equal to 0. So we have a quadratic. And then for any of the negative x values, we have the linear function 1/3 x. Okay, so for x greater than or equal to 2, we're going to graph the parabola x squared plus 2, but we're only going to graph half of the parabola where the x values are 0 or greater. So remember that with this particular quadratic, it's a shift up of 2, so we have a vertex normally at 0, 2, but it's only going to graph the right side of the graph. And on the other side, we're going to graph the linear function 1/3 x, slope of 1/3, y-intercept at 0. Now with the 1/3 x, we're not including 0 as our endpoint, but we want to include all the possible x values up to 0. So, as close to 0 as we can get. So we're just going to put an open circle at 0 to show that endpoint there. And on the x squared plus 2 graph, we do have an endpoint at 0, 2. Okay, sometimes what happens with the absolute value function is we graph it as if it were a piecewise graph. Let's see how we can write the equation in a piecewise format. Let's first plot some points. So we know that if we take the absolute value of a number, we're really just looking for the distance away from 0 on a number line. So if we're at -3, the distance would be 3. Remember, distance is always measured as a positive value. So that's going to be true for -2. We're just going to take the positive value of it, and for -1. Now that would be the same as saying taking the opposite of that negative value. So it would be like taking the negative of -3, and that output would be +3. So we're just taking the negative of the x value when the x values are already given as negatives. Now, if it's 0, your output's just going to be 0, not taking the negative of it. We're just leaving it as it is. And the same with 1, 2, and 3. So that means whatever value we put in for x, we get out x. So x and y are equal. So our piecewise function becomes x if the x value is greater than or equal to 0. We're just going to leave it as is. But we're going to take the opposite of the numbers if we have a negative number to start with. So that gives us the second part of the piecewise graph, which is -x for any x values less than 0. So when we go ahead and plot this, we actually have two linear functions. The first one is y equals x. So we have our slope of 1 and our y-intercept is 0. For the second one, our slope is -1, and our y-intercept still would be 0, although it's not defined at 0 for that part of the graph. We already have that point at 0, 0 from the right side of the graph, so we don't need to exclude it from our graph. We want to include it because it's in part of the graph. Okay, so we ended up with our V-shaped graph, which is the absolute value of x. All right, thank you for tuning in to Demystifying Math.